explain the power steering in brief. To understand the power steering, let us consider a steering arrangement with rack and pinion steering gear. We know that as the steering wheel rotates, the steering column rotates with it. This causes the pinion to rotate, which in turn moves the rack linearly, thereby providing steering to the vehicle. Now, when a car is steered manually, the driver supplies all the steering force. For medium and large vehicles, this becomes very fatiguing, as very large amount of torque is required for steering. To reduce the effort of the driver and to provide easy steering, a hydraulic assistance is provided with the steering system. This hydraulic setup, which assists the driver in steering easily, is known as power steering. Now let us understand it in brief. A typical power steering setup used in rack and pinion gear steering can be shown as: it mainly consists of an engine-driven hydraulic pump, a power unit located in the rack housing, a rotary valve provided above the pinion gear, and a fluid reservoir. The power unit consists of a piston cylinder arrangement. Here the working cylinder is formed with the rack housing, and a piston is placed at the middle of this cylinder. Both ends of this working cylinder are provided with proper sealing to isolate it from the rack. A connecting pipe is provided in the cylinder on each side of the piston for inlet and outlet of the fluid on both sides. These connecting pipes are connected at other end of the rotary valve. The rotary valve is located between the steering gear input shaft and the pinion gear. It consists of an inner member, which forms part of the input shaft, and an outer sleeve member, which is connected to the pinion gear. Now, when the steering wheel rotates, both members rotate in the steering gear housing. However, there is small relative movement between both the members. This is because a torsion bar is provided inside the inner member, which is connected to the input shaft at one end and to the pinion gear at the other end. Now, when the steering wheel is turned, there is resistance from the front wheels at the road surface. This resistance is transmitted through the rack to the pinion gear, which causes the input shaft to twist slightly on the torsion bar. As the inner member is also attached to the input shaft, this twisting provides a relative movement between the inner and the outer member of the rotary valve. It is this relative movement which causes the fluid to flow through the valve into the working cylinder and work on the piston, thus providing the steering assistance. It is to be noted that the input shaft is allowed to twist only for a small angle before it contacts a stop on the pinion gear. This is done to provide manual steering in case the power steering fails. Now, the inlet and outlet of the working fluid in this valve takes place through holes drilled in the outer sleeve. Now, let us understand its working. When the vehicle is running and the steering is in neutral position, the inner member of the valve allows equal amount of fluid to pass in both sides of the piston and return to the fluid reservoir. This equal amount of high-pressure fluid keeps the piston in middle, thus keeping the wheels straight. Now, when the steering wheel is turned, the inner member of the valve rotates a little. This causes the high-pressure fluid coming from the pump to flow in the side matching the turning action. This high-pressure fluid then pushes the piston towards the other side of the cylinder. Also, the fluid from the other side of the piston is returned to the rotary valve, which then sends it to the reservoir. This movement of the piston causes the rack to move linearly, thereby providing effective steering without much effort applied by the driver. Now let us summarize the power steering as: